In today's video, I'm going to make a bunch of optical centre punches. I made this one off camera just to see if I'd like it, and I think it looks great. Before I get started though, I'll quickly show what an optical centre punch is for anybody who doesn't know. It's a tool for precisely lining up a centre punch to the marks on your workpiece. You do that with a lens, and you remove that from the body and replace that with the centre punch. I've wanted one for quite a while, and because I made a couple of jigs to make this one, I thought I'd get some more use out of them and make a bunch of them to give away. The bodies could be made from pretty much anything. I'll make most of them from aluminium. I will make one from brass and one from steel, and I'll start making the aluminium ones first. I'll be using the lathe and the milling machine, but at the end of the video I'll show how you can make a really simple one out of wood using just the drill press. Every now and then I enjoy working on a small production run. It can make the project more interesting with some problem solving and working out a different way of doing things. I'm not actually making that many of them, but with this process I could. I'm sure that there's even better solutions to some of these tasks, and I think it'd be awesome if you shared some of your ideas and how you'd improve on them in the comments. Straight away I can think of a better method than what I'm doing here. It would be much faster to use a drill and a reamer the size of the rod that I'll be using for the centre punch. Because I don't have a reamer that size though, that's why I'm boring it out. The next step is completely unnecessary, but I really like the look of it, so I'm going to add these concentric rings. To line up the tool, I'm using the point of the punch that I already made. Then I can zero the DRO, and from there I can set the radius for each ring. Even though they're not needed, I reckon when they got some paint in there they'll look pretty effective, and they only took about a minute to cut them all. Next I'll part it off, and I really like this trick where you use the end of the rule to find the edge of the parting tool. From there I can zero the DRO, come across the correct amount, and this will ensure that all the parts are the same length. I probably should have deburred it while it was on the lathe, but this hand deburrer from Niroc Tools works awesome. Now I need to take those processes and make the rest of them. If I'd have had enough and it wasn't so expensive, I would have made them all from brass. It's really nice to work with and it looks great as well. I decided to do one with steel, which I'll nickel plate later, and that one is going to be for myself. That's all the bodies turned and bored out, and they would work perfectly well as they are, but they will be even better with a cutout, and that's to hold it firmly in place and make it more comfortable. To make the cutouts I'll use an annular cutter. I wasn't sure if this was going to work, but it worked well on the prototype. I also made this fixture to hold the pieces while I work on them using different operations on both the lathe and the milling machine. I milled 4 flats into the fixture, and I'll use those to reference the 4 cuts that I need to make with the annular cutter. I could have turned this feature on the lathe. It would have been more of an hourglass shape, but I really like the geometries that these 4 cuts make, and I reckon it's far more interesting. Anyone that's worked with aluminium will know that it can build up and stick to the edge of a cutting tool. Using WD-40 definitely helps with that and stops it from gumming up. That's the first cut made, and it went well. Like I said, I wasn't sure when I very first did this. I don't like making cuts that are halfway into a piece, but it seems solid enough. Even though it probably would be a bit quicker on the lathe, I don't think it would be that much quicker, and I think it's worth the extra time for something that I reckon looks much better. I did think about making 5 sides, and maybe that would have been worth it, because I think that would look pretty cool too. I'm happy with that, so now I need to do the rest of them. I did have a bit of a problem on the second one. I started the last cut a bit too fast and it dug in. What I've realised is the start of the cut needs to be fed in slowly, and then when it's fully engaged you can go much quicker, and the end of the cut's happier when it's fed in slow too. I'm using 2 arms on the levers to brace against each other and keep good control. I did try the fine feed as well, but I was happier doing it this way. The brass cut very nicely, and as I said earlier, if I'd have had the stock I would have made it all from it. It really is very nice to work with. I'm worried about the steel one though. We'll see how that goes. I don't know what I could do with the slugs that are left over, but they're pretty cool. Right then, here we go. Fingers crossed with the steel one. No, I don't think that's going to work. I have to say though, even though I was using the fine feed, I think I could have gone a bit slower. Anyway, plan B, I'll grind them instead, and I've used one of the other ones to set the heights of the small wheel on the grinder. I really don't think making this from steel is a good idea. I just wanted to experiment with different materials. I think it'll be pretty cool though when it's done. It's just not the material of choice. There's still a small nick there from where the cutter dug in, but all these edges need rounding over later, so I should be able to round that out. I'm clamping a bar to it to use as a visual guide, which I can line up with the back of the tool rest, and this will keep this grind parallel with the first. This doesn't need to be super accurate. I don't want it looking wonky though, so I'm trying my best to keep it as accurate as I can. With the third grind, I'm just trying to keep it centered just by making adjustments, and then when I've got enough ground, then it's easy enough to keep even pressure on until I get to the required depth. That's actually working really well, and I probably should have just done that from the start. That's all of them done. It was a bit of work, but not too bad, and I reckon it was definitely worth it. I'm not sure what you think. Anyway, on to the next task, which is to cut a groove for an O-ring, and I've ground down a piece of high-speed steel to do that on the lathe. The O-ring isn't essential, but it definitely helps in keeping the body firmly in position when swapping out the lens for the punch. You can probably see that I'm going in on an angle, and this will leave the inside diameter as a dovetail for the O-ring to hook over. I need to make a second pass just to take off the smallest amount so the O-ring can fit into the groove. Now I need to go through and do the rest of them. They all went very well. The brass, just like before, is easy to do, and the steel one, I did have a slight problem with it. Cut fine, but right at the very end it broke the cutter, but it was deep enough that the O-ring fit. Now for an interesting part of the project, the lens. It's actually very easy to do, and I'll make it from this 20mm clear acrylic rod. It just requires some basic turning on the lathe, but as I mentioned earlier, at the end of the video I'll show how you can do this just on the drill press. I had to play around to get a good finish, and I found that using high speed steel was the best with a medium speed and not too fast. Because I have a few to make, I've set up the turning tool on the absolute setting and the parting tool on the incremental setting. This means that I can keep swapping out the two tools and keep my coordinates for each one. I'm using the turning tool as a stop, and I've set that 0.5 millimeter over what it needs to be, and then I turn it back to the correct length. That's all of them cut. Next I'll finish and polish the ends, and I'll start with the top, which will have a magnified view. It's curved, and on the original one I just did that with a file and then sanded it on the lathe. For these ones I've ground a form tool from high speed steel, and hopefully it'll keep them all consistent. It's working well enough, but I can't seem to get a clean cut on that centre. I've tried different speeds, and I've even tried coming in on the opposite axis. I need to sand it next anyway, and that should remove it. I'm starting with 180 grit. I'm going through 7 different grits and I'll end up on 2500. And to get a super fine finish, I'll use some cut and polish. I'm using a microfiber cloth and it's a very small piece. I've got it between my fingers. If you're ever using a cloth on a spinning tool like this, whatever you do, don't wrap it around your finger. If that grabs, then you could be in real trouble. I reckon that looks amazing. It was very easy to do and it only took a couple of minutes. I still need to polish the bottom, but while I've got it set up, I'll go through and polish all the tops first. With all of these tasks and showing the extra pieces, I wasn't sure how much to show, but I wanted to give a taste of the whole thing, so I'll try and get through it quickly. That's the tops done. Now for the other end, and that's quite interesting too. They're not curved, they're flat, but they still need polishing, and they also need a crosshair on. I can hold them in an ER32 collet and putting it in from the back, they're just long enough to come through the front. I'll polish them all first, exactly the same as before with the 7 grits up to 2500. I've ground a point on this high speed steel and I'll use that to scratch on the crosshairs. I don't have a way of indexing on my lathe, so I've attached a magnet, and to that I'll attach a digital angle block and then I can use that to position and reference the chuck. With the angle zeroed, I can touch off and then zero the DRO as well for the depth of the scratch, and I'll set that and make the first mark. I'm pretty confident that I have the point of the tool on centre, but just in case I'll go through 90 degrees and take another pass from the other side and then 90 degrees again. I probably should have already mentioned this, but if you do want to make one of these, I'll put the drawings up on the free plan section of my website. I think if you're going to make a tool like this, then it's worth the effort to make sure that everything is accurate. And to highlight the crosshair, I'll just use a red Sharpie. I think if you only have one to do, that's probably the best way to do it, but as I've got a bunch of them to make, I think it'll be easier and more repeatable on the milling machine. I quickly made a holder for that same pointed tool that I'll put in a collar to the milling machine. The first thing I need to do though is lock the spindle. I'll hold the acrylic lenses in a square collet block. I'll then be able to make one mark and then move it around in the vise and make a second mark. I'll only make the marks from one direction this time. I'll just be extra certain that I've got that point on centre. I haven't shown it, but I've already polished the next one on the lathe off camera. The crosshair on the first one was a little bit too wide, it was too deep, and I'll sort that out later, so this one I'm aiming to do it a little bit more shallow. I'm using the paper just to make the process repeatable so all the parts come out consistent. I can zero the DRO, back the tool out and move it over the same amount each time. I'm setting it up on this first one and I think that is just a bit too shallow, so I've just moved it over a touch more. And this is why I'm doing it on the milling machine. It's much easier to take that collet block out of the vise, move it around 90 degrees and make the next mark. I still need to take it to the lathe to finish it off just like I did before. I reckon that looks great, and here's the first one next to it to show you how much finer it is. Here's the whole process in one view. I start at the lathe, go through the grits to polish it up, over to the milling machine to make those marks, and then back to the lathe to finish it. And all of this is in the same collet and collet nut throughout the process, and the whole thing takes about 2 minutes. I reckon the lenses all came out great, so next I'll start the punches, and for that I'm going to use this hardened high-speed steel. I made this simple jig to accurately grind a point on the end, and it would have been easier to do this with high carbon steel in a softened annealed state, which I could harden later, but I already had this hardened high speed steel that was for another project and never got used, and I wanted to use it up. I'm just roughing it out on the belt grinder, but I will finish it on the surface grinder and get them super precise. The way to do this would have been with a spindexer, but I don't have one, and that's why I threw together this jig. I'm adding a stop collar. I could have used that on the belt grinder, but I didn't worry about it there. But this is what's going to make it more accurate by stopping the depth of the grind. I keep nudging the table in, grind a bit more off, nudge it in again, and so on until I get a full bevel that comes to a point. Just out of curiosity, I'm checking how hot it is, but it doesn't really matter. There's no way high-speed steel's going to lose its temper through a bit of grinding. That looks super nice, so I'll do the rest of them. And I should mention that there is a downside to using this high-speed steel. Not only is the pointy end hardened, but because the whole thing's hardened, the striking end is as well. So it's not ideal to hit that with a steel hammer. It's possible a fragment could break and shoot off at high speed and do some damage, but realistically you're only ever going to tap it if you did hit it with a steel hammer, and to address that you could just use a soft-based hammer like brass, copper, nylon, or even a wooden mallet. Next I'll clean up and finish the striking end. I'll do that in the cordless drill, but being 15mm it won't fit in the chuck. To get around that I've quickly made this holder. I'm just rounding the ends over, and by taking those square corners away, if anyone were to hit it with a steel hammer there'd be less chance of that fragmenting. I thought about annealing the striking end, but as high-speed steel is an air hardening steel, that was never going to happen. But on the prototype I was curious, so I tried anyway. I put it in the induction forge, I heated it up to a super high heat, I held it there for about a minute, then let it cool down, and it was just as hard afterwards. High-speed steel really is amazing stuff, but anyway, that's the punches finished. We're almost there, the punches are done, the lenses are done, I just need to sand the bodies and take off all the edges. I'll start with the scalloped areas first, and I'm doing that with a small wheel attachment again on the belt grinder, and this thing's been super useful in both of my last two projects. I'm changing the belt to a higher grit, and I did actually change it a third time, which I don't show. I ended up at 400 grit. I could have gone higher, but it left a bit of a brush finish, which I quite liked. Now I'll put them back on the lathe and soften up all the edges. I do quite like the sharp edges, it looks pretty cool, but it just isn't comfortable to hold. The aluminium will oxidise and dull down a bit. The prototype one has already done that, and it's only been a few days, and I think it looks much better. That's all of them sanded to a decent finish, so next I'll clean the steel one ready for nickel plating. If you've watched any of my other videos, you would have already seen me do this. It's very easy. It's electroless nickel plating. You just heat the solution up to a certain temperature and leave it in there for 15 minutes. While it's in there doing its thing, I'll clean up the others ready to put some paint into the rings. It came out pretty good, and I'm happy enough with it, even though I think I have had better results in the past. I think the solution may be getting a bit old, so next time I'll mix up a fresh batch. While the paint's drying on those, I'll modify the fixture that I've been using to hold them on the lathe and make it into an expanding mandrel. I probably should have done this from the start. It will be a better solution as it won't have a washer covering up part of the face. It's a pretty crude modification, but it works perfectly, and as I said, I should have done that from the start. I reckon the rings look great, and I'm definitely happy enough with them, but I think the first one, they do look a bit better as I made them a bit wider. I just need to put the O-rings in and then we can give it a go. And by the way, the aluminium ones I'm going to give away to my Patreons. The brass one is for my mate Corin from Nerock Tools, and also he's planning on making a bunch of these. If you're interested, I'll put a link in the description. I reckon it's a really cool tool and a great little project, but there is room for error when you're using it. You really do have to pay attention to get it accurate, even though it's far more accurate than using a regular centre punch. I reckon that came out pretty good, and I'm confident that I've made mine super accurate. The point is definitely in the centre, the crosshairs are too, and they fit in the bore really well. Anyway, let's do a few more. They're not too bad at all. I wouldn't say everyone is bang on in the centre though, so I'll have another go and pay a bit more attention and see how good I can get them. I do think that it's pretty good, and I'm probably nitpicking. Anyway, I'm going to move on and I'm going to make the simple one that I promised to show earlier. I'll make it from a piece of wood, 12mm drill rod and a piece of acrylic to match. I'll get through this quickly, and as I said earlier, I'm just using basic tools, and the main thing I'll be using is the drill press. I didn't get the magnifying end quite right, it doesn't focus, but if you turn it over you can see through it clear enough. I just made the end a bit too bulbous, so I need to make that more shallow. It's not difficult to do though, and it really did only take 2 minutes to redo it, and it worked out perfect. It's probably not impossible, but difficult to put a crosshair on with basic tools, so this time I'm just going to put a centre spot, and I'll do that with a small drill bit. I've used this technique before on other projects, and I'm transferring the drill bit from the chuck into a vise. I'll clamp that vise down and then I know it's centered to the chuck. I don't think this will be as accurate as the other methods I've done, but honestly I think it's more than accurate enough for its purpose. Next I'll grind a point on the drill rod, and as it's only 12mm this time it'll fit in the drill, and I'll also do it with an angle grinder just to show that you can do it with basic tools. If you do this though, make sure that it's very secure and you are doing it at your own risk. I'm just giving it a finer finish on a sharpening stone, and you can see here that it's running very true in the centre. I cut it to length off camera, and this piece isn't heat treated, so I'll do that next. You could do this in a forge if you have one, but a couple of blowtorches work well on a small part like this. I just heat it up to cherry red and then quench it in vegetable oil. It's now super hard, but it's brittle as well, and that point would break off, so it needs tempering back a little bit. I do that by heating up the striking end and watch the temper colours run through. When the point's a straw colour, I suspend that state by cooling it in water. If it works well enough, then I think it's a cool little project and achievable in an afternoon. But anyway, let's give it a go and see if it's any good. We're looking at the middle one of the three, and I reckon that turned out pretty good too. You could make it whatever shape or finish that you want. I'm not going to worry about that, but hopefully it shows that you can make one with fairly basic tools. Even though I made the project more difficult than it needed to be, I really like the design. I'm super happy with it, and I think they turned out great. Hopefully you liked it too. It's going to be a super handy tool and much better than using a regular centre punch by hand. Hopefully you enjoyed the video. Thanks for watching, and I'll see you on the next one.